Hi, my name is Jan and I will show you today how we have used our software product Yanomaly to monitor and analyze the data of 4 different pumping stations of Aquafin. Behind me on the screen you see Yanomaly and in particular the status dashboard, which is one of the ways you can look at the results of Yanomaly here under the dashboard menu. Other options are the data option, where we specify which data Yanomaly should use. With filters, we can look at the raw data and also select interesting pieces in that data. And under ensembles, we specify the models that should be used to monitor a pumping station. Here on the bottom left, we have organized the pumping stations in a hierarchical fashion. Here we have 2 levels. We have the province, and then under the province, we have the pumping station, but we had data for only 4. So there is only 1 station per province in this case. And you see that also here in this kind of parliament view, where you have the locations in gray and then the ensembles or models in color. And in this case, you see that the status is blue, which is unknown, which is perfectly normal because I'm looking at the live view with the data of the last hour, but we're not streaming live data. So we have to look back in time to the moment when Aquafin delivered data to us, which is 2019. And here this is a particularly interesting case because at this time, 12 o'clock on 14th of August, there was an repair reported. So an intervention was reported on station 1911. And if we see a few days before that, from August 12 to August 14, we see indeed that there is a critical issue at station 1911. If we push on that, we come to this view, which is the anomaly score view. Anomaly score here is from 0 to 1, 1 meaning very abnormal, 0 as here in the beginning, meaning everything is perfectly normal. Here on the right hand side is where the intervention was reported. Probably the real intervention happened here when the anomaly score drops from high back to the normal value 0. But you see indeed that the anomaly more than a day ahead of time already starts reporting higher anomalies, initially short peaks, but then here a longer period, and then finally here a very long period of many hours where the anomaly score is elevated. So that seems to indicate that the anomaly has predicted this issue. So let's now look in more detail. So I have selected here this moment in time, and then we see at that moment the anomaly score is 97%, of which about 25% can be attributed to the current of pump 2, another 23% to the flow of pump 2, and 21% to the flow of pump 1. And then the remaining 30% or so is because of all the remaining other sensors in that pumping station. So let's now look in more detail at the current of P2. And we see here current as a function of time. You see first the normal evolution, and then here at this moment is where I selected in time where the anomaly score was very high. And you see that the actual current, which is in the light blue, is indeed much higher than the predicted or expected current by anomaly, which is in the dark blue. So this is the prediction of that current by anomaly for these circumstances in which that pumping station is operating at that time. And you see here, even before this long period, you see that the current is behaving abnormally because normally it's quite stable, as you see here. But here it's up and down, and then here also it is lower than expected, higher than expected. If we look at the second signal, which is the flow has this normal behavior, and then around here, this moment, you see that the actual flow is lower than the predicted flow. So this is interesting. So the current is higher, the energy consumption is higher, but the resulting flow is lower than expected. And also here you see this erratic behavior. Finally, the flow of pump 1 looks like this as a function of time. And here at the moment of this continued high anomaly score, you see that the real flow of pump 1 is higher than the expected flow of pump 1. And also here you see a strange behavior just before this major incident. So now if we look at the raw data in the filter view, then you can select here the same time period. You select a few raw data signals that you want to see. And let's start first by looking at level. See, level normally is low, then it goes high, probably because there is heavy rainfall. You see the pumps pump more and longer, and can bring the level back to a lower value. Here it's back to low, but then it starts where the period of high anomaly score is. You see the level is really going up again. And strange enough, indeed, you see that the current of pump 2 is about at the same level as here, but that the flow is indeed much lower than it is here for the same current. So that is strange. And you also see that the flow of pump 1 is higher than what it normally is over here, and also what it is here over here in this normal period. So it looks indeed like Yanomaly has been able to identify this issue, and a potential explanation of this is that there is some debris in the suction channel of pump 2, leading to a lower flow despite the high current, for trying to pump more of the water out of the basin with pump number 2. So I hope in this way we have been able to illustrate how Yanomaly can be used to predict and analyze issues with pumping stations. I thank you for your attention.